can build an entire world out of apps, forms, chat boxes, but when it matters the most, or when you want to get something done quickly, we still pick up the phone. Because voice is our oldest and most effective interface. It's our default setting. We don't need any user interface training for it, and it spans across generations. It's our most comfortable way to communicate. This deep-rooted familiarity is exactly why conversational voice agents are becoming so powerful, because they don't ask users to adapt to a technology. The technology adapts to the users. Today, we are going to build a reception agent, a fully autonomous AI voice receptionist that can handle inbound calls, can update records, and can schedule appointments in real time. You can call it, talk to it, and you can hang up with a confirmed booking. Let's take a look at how it works.
Hello, Ari Johnson. Welcome back to the clinic. I'm Matthew, your AI receptionist. How can I help you today?
I'd like to book an appointment.
Of course. What date would you prefer for your appointment?
Do you have any available appointments tomorrow at 11 a.m.?
It looks like there are no available appointments tomorrow at 11 in the morning. Would you like to suggest another date and time?
Are there any available appointments day after 10 a.m.?
We have an available appointment on Saturday, the 13th of June at 10 in the morning. Shall I go ahead and book that for you?
Yes, please.
Great. Just to confirm, that's an appointment for Aria Johnson on Saturday, the 13th of June at 10 in the morning with Dr. Sarah Lynn. Shall I proceed?
Yes.
Perfect. Let me confirm that booking for you now. Your appointment with Dr. Sarah Lynn is confirmed for Saturday. You'll receive a WhatsApp confirmation on the number provided. Is there anything else I can assist you with today?
Yeah. Do you guys have a pharmacy?
Yes. We have a small in-clinic pharmacy that stocks common medicines, first aid supplies, and over-the-counter medications. For a full-service option, Med Plus is just a 2-minute walk away on 4th Cross. And Apollo Pharmacy is about 5 minutes away on Coromangala First Block. Can I assist you with anything else?
No, that's it. So we just saw how it works. Now let's dive into building it. We'll start off with an overview of all the components and how to set each one up. Then we'll get into the code layer by layer. And finally, by the end of it, we will have a fully autonomous AI voice receptionist that answers our calls and books appointments for us. I will be building it for a clinic, but you can feel free to swap out the system prompt and make your tweaks to build this for any business you'd like. So let's start with LiveKit. When you wire up a voice pipeline yourself, you have to handle transcribing the audio, putting it through an LLM, and then synthesizing a response through a TTS. All of this adds a 2 to 4 second delay, which in a conversation feels like somebody is ignoring you. You could use a WebSocket, but while WebSockets work well with text and data, they can sometimes cause stutters or pauses with voice. This is where LiveKit comes in. LiveKit is a streaming infrastructure which allows us to bring this latency down to what feels natural in a conversation without all the trouble that comes with a WebSocket. It uses WebRTC, which is designed specifically to stream conversations. Let's look at how to set it up. We have to go to cloud.livekit.io. And from your project settings, copy the URL, API key, API secret, and SIP URI and drop them into your .env file. On the console, go to telephony, SIP trunks, and create a new trunk. We have to give the trunk a name. I'm going to call it clinic. And select inbound, set the allowed IP addresses. So if you want to allow all IP addresses, you can set this to 0.0.0.0/0. Leave the phone numbers blank for now. We'll fill this in once we've created the Twilio account. If you switch to JSON editor, your JSON should look something like this now. And click save, and that's it. We've created our SIP trunk. Now we go to telephony, dispatch rules, and create a new dispatch rule. We have to give our dispatch rule a name. I'm going to call it clinic. We need to give it a prefix. Again, I'm going to give it the prefix of clinic. And we also need to give it an agent name. I'm going to call it clinic agent. So remember this agent name. It has to match the one in your code. Or when you place a call, the call will connect, but all you will hear is silence. If you switch to JSON editor, your dispatch rule should look something like this now. And that's it. We've set up LiveKit. Connecting your software to a phone line or sending an SMS would mean negotiating contracts with multiple telecom carriers, setting up physical servers, and managing the telecom protocols. All of this is a grueling process that could take months on end. So we have Twilio, a cloud communications platform, which turns the global telecom network into simple software APIs. So it acts as a bridge between the internet and phone networks. So you can make real phone calls, send SMSs, or even set up an entire customer support system. So coming to the Twilio setup, we need to go to console.twilio.com or oneconsole.twilio.com. They recently updated their console. Create an account and then copy your SID, auth token, and your phone number and paste them into the .env file. On the console, go to TwiML bins and create a bin. You have to give your bin a name. I'm going to call mine clinic. And you have to write this in the TwiML section. So you have to open a response tag. Under it, open a dial tag. Under that, you open an SIP tag. So in the SIP tag, your content should be of this format. So SIP colon, phone number, @SIP URI, and then transport equals TCP. And then you close the SIP tag. You close the dial tag and you close the response tag. So you have to replace the phone number with your Twilio phone number and the SIP URI with your SIP URI. So for example, if your phone number is +12345, your phone number should be written this way. It should be 12345. And if your SIP URI looks something like this. So SIP colon abc123.sip.livekit.cloud. Your SIP URI should be replaced with abc123.sip.livekit.cloud. Now your TwiML bin is set up. Now you go to oneconsole.twilio.com, go to products and services, numbers and senders, click on your phone number, and in the voice and emergency calling section, click on edit configuration details. So select your configuration method as the one that has the TwiML bins in it. Set your primary method as TwiML bins and select the bin you just created. Now that your Twilio number is active and routing via TwiML, go back to your SIP trunk on LiveKit, configure the trunk and add your Twilio phone number to the phone numbers section. So if your phone number is +12345, add it with and without the plus so that LiveKit knows to accept the calls from this number no matter which format it comes in. Now, when you switch to the JSON editor, your trunk should look something like this. Optionally, you can also set up WhatsApp to receive WhatsApp confirmations. We'll be covering this in a later section. Twilio gives you a sandbox number to do all the testing for your WhatsApp messages. If you go to console.twilio.com, under messages, send a WhatsApp message. You just follow the instructions here to set up a recipient to receive messages from the sandbox number. This is the sandbox number. You have to put it into your .env file in the format of WhatsApp colon this number. This is just for testing. So if you want to take this into production, buy a WhatsApp business number from Twilio and use that instead of the sandbox number. And now we have Twilio set up. So coming to the speech to text for our project, OpenAI recently expanded their ecosystem by introducing a dedicated streaming speech to text model. It's called Whisper Real-Time. So for those of you who have used the previous Whisper models, you know the frustrating delay that's caused by waiting for the entire input to be processed at once. But this allows for true streaming. So it's not available on their free tier. You'll require a paid OpenAI API key to use Whisper Real-Time. You can head over to their platform and get your API key. You can also choose to use a different STD provider like DeepGram Nova 3, for example. We also require a large language model to act as our central reasoning engine for this project. I'll be using OpenAI's GPT, but you can choose to use any other provider you like. Gemini offers a good enough free tier to try this out. So now that our input has been transcribed and our LLM has decided what to say, all of our speaking in the project will be handled by Murf Falcon. It's the consistently fastest text-to-speech model with 130 milliseconds time to first audio. It's built and optimized specifically for real-time conversational applications. So you can head over to murf.ai/API, get your API key and drop it into your .env file. Please keep dropping your keys into your .env file so we can dive straight into building our agent after this is done. So for an AI receptionist to be genuinely useful, it can't just talk to a caller and then forget all about it. It has to keep track of booked appointments, identify returning callers, book new appointments, and to do all of this memory handling, we will be using Supabase as our database. It's an open source Firebase alternative, and it gives you a completely managed, scalable database with an instant API. So head over to supabase.com, create a project, create an account, and then create a project. Copy your project URL and your ANN key and drop them into your .env file. This next section is optional, but it's a really nice thing to have for an agent to make it actually useful. For human staff to have visibility into what the agent is doing, we give it the capability to do Google Calendar blocking. So to block off a slot on a calendar based on whatever your requirement is. So for the clinic, it will be blocking off appointments on the doctor's calendars. So to do this, you'll need to head over to Google Cloud Console, enable Google Calendar, create a service account, and then come back to Google Calendar and create calendars for, in the case of the clinic, we'll be creating it for the doctors. And the proper detailed steps are in the blog linked in the description. You can set it up. We'll be diving into this in a later section. So we have now gone over all the major components and how to set each one up. And I'm hoping you've got all your credentials and you've dropped them into your .env file. If you haven't, pause here, get your credentials and come back so we can dive into building our agent. If you have any doubts along the way, you can refer to the blog linked in the description. It has all the detailed steps required to set up each component. So we'll start with the core voice loop. In this layer, we will be getting our agent to connect to a call, speak to us, and to adopt a persona. So before we write the logic for our voice agent, let's start by installing the necessary packages and prepping up our terminal. So run these in your terminal, starting with creating a virtual environment. So we'll be running Python-m, venv, and then we have to activate our virtual environment. To activate your virtual environment, I'm on a Windows PowerShell, so I will be using venv/script/activate.ps1. But for Mac and Linux, you have to use source venv/bin/activate. Now you have to create a requirements.txt file in your project root and add the following packages to it. So if you look at my screen, these are all the packages. This is available in the blog linked in the description. You can just copy it and put it in your requirements.txt file. And this covers LiveKit, it covers Twilio, and it covers all of our other plugins that we require. Now run the command to install all of them, pip install requirements.txt. And that's it, our terminal is prepped and we can dive into writing the code logic for our agent. One more thing to remember, the dispatch rule that we created when we were setting up LiveKit, the JSON file of the dispatch rule needs to be copied and you need to save it to your your project root as dispatch rule.json. So let's start off by defining how our receptionist should behave. In the root of your project, create a folder named prompts and create systemprompt.py within that folder. By keeping the prompt in a separate file, we can easily make any tweaks to the persona or change it as a whole if we want to. So in systemprompt.py, I have written it to be an AI receptionist, but you can tweak it to match whatever persona or whichever business you're building this for. This particular prompt for the clinic is available in the blog linked in the description if you want to refer to it. So we are defining exactly how a receptionist should behave. I'm saying that it's the receptionist for a clinic, and I'm asking it to identify itself as an AI at the start of every call. It has to use a warm and calm and professional tone. And I've given it some instructions, and now I have returned the system prompt. So coming to the core logic for our agent, create agent.py in your project's root. This will be the file that wires everything together and controls all the functionalities of our agent. Start by importing all the necessary modules in the beginning. Then we will be importing our receptionist personality from prompts system prompt. We'll load the .env file so we can access our API keys without having to hard code them. Set up logging so we can watch what our agent does, and it becomes easier to debug our agent later on. And we'll fetch our environment variables. I have the OpenAI API key and the Murf API key. You can switch this for whichever LLM you're using. If you're using Gemini, you can import your Gemini API key. So in a normal phone call, the person who's picking up the phone always speaks first. But if the AI waits for the user, the caller will think that the line is dead. So instead, we hard code an opening line so we can trigger it immediately as soon as the call connects. So I'm going to keep my opening line pretty simple. I'm going to thank the person for calling the clinic and then ask how I can help you today. So there is no awkward silence in between when the AI has answered the call. So we pass the instructions from our system prompt to the LLM so it knows it's acting as a clinic receptionist. Later on, this is the section where we will be adding all of our other tools, such as the booking appointment, or when we add cancelling and rescheduling those, and all of the other tools that we'll be adding will go in this instruction section. So AI models also suffer from a cold start latency. So if we wait until the user speaks to load the voice activity detection model into memory, there would be an awkward pause where the user hears nothing. So instead of this, we use a pre-warm function to preload the VAD waits the moment the server starts to eliminate that lag. LiveKit rooms generated by Twilio SIP trunks usually start with a specific prefix. We check this so that the agent knows whether it's talking to a real phone line or just a local web testing environment. So this function is phone room. We'll check this. And now coming to the engine of the voice agent. So every time a new phone call comes in, LiveKit fires up a new instance of this entry point to handle the conversation. So this is the entry point function. We will first connect to a LiveKit room. Since it's a phone call, we need only audio. We don't need any other forms of communication. And now we are going to define all of our providers, the STT, the LLM, and the TTS. So starting with the speech to text, these are going to be the ears of our agent. I'm going to be using Whisper Real-Time. So this is the format in which the Whisper Real-Time definition should be. So I'll be specifying which model I'm using. I'm going to be setting real time to true, setting the language to English, and then telling it where to find the OpenAI API key. So if you want to use DeepGram, this is the format in which you have to write your definition. And coming to the large language model, this is the brain of our agent. I'm going to be using OpenAI with GPT-4o Mini, but you can swap this for any other LLM. So the definition for this is written this way. So I'll be specifying which model I'm using and where to find the API key. If you're using Gemini, for example, this is how the definition would look. So google.llm model equals Gemini 2.5 Flash if that's the model you're using, or whichever. You can find their models on their website. And you tell it which API key to use, and that's it. That's how you define the LLM. Coming to the speech to text, which will be handling all of the speaking for our project. So we're using Murf Falcon. So to set up, to define Murf Falcon, we do TTS equals Murf.TTS. We set the voice ID. I'm going to be using Matthew. And we set the locale. In this case, it's ENUS. And that's it. We have all three of our providers set and we're good to go. So agent session is what takes our ears, brain, and our speaking and wires them into a single continuous streaming loop. So it automatically handles the turn taking and all of that. So the user interrupts the agent, the session stops the TTS and activates the ears to listen to what the person is saying. So we load our STT, our LLM, and our TTS and our voice activity detection model, which we will be pre-warming. As the server starts, it will be loaded into the memory. And now we load our receptionist instructions and start the session in the room. So we wait up to 20 seconds for the Twilio SIP trunk to bridge the audio stream. If no one connects, we will log the error and shut down this instance. So we don't want it to infinitely keep waiting for a call to connect. And once a caller connects, we play the opening line immediately. And we set allow interruptions to false so that, it doesn't take any interruptions when this is being played. It ensures the agent finishes the opening line and then it starts listening for the caller's response. And then we keep the worker process alive as long as the phone call is active so that it doesn't randomly disconnect in between your phone call. That would be frustrating. Imagine talking to a receptionist and they hang up on you. We would be annoyed, right? So finally, we come to the server initialization. This is where we start the LiveKit worker. So you must make sure that your agent name here matches the one in your LiveKit dispatch rule, or all you'll hear is silence. The call will still connect, so it'll seem like everything's fine, but you'll hear just silence. And this is it. We have our core voice loop wired in. And now when we make a call to our agent, it will answer and it will speak to us. So now we have to run the agent using Python agent.py start. And once you see registered worker in the logs, you can place a call to your agent and it will speak to you. Having a receptionist who can only speak to you, can't make any appointments, and forgets the conversation the moment you hang up isn't of much use to anyone. So in this layer, we are going to be giving our agent memory and giving it some capabilities so it can recognize returning callers and book actual appointments. So to start with, let's create the tables where our agent will store the details. In your Supabase dashboard, navigate to the SQL editor and run this query. So this query is available in the blog linked in the description, as well as under SQL create tables.sql on the repo. You can refer to either and paste this in and run it. So now we're adding the memory. Go to your project root, create a folder called tools and create memory.py inside it. So this is the file that's going to be handling all of your database functions. So Supabase Python client is generally synchronous, it's blocking. So we don't want our entire agent to hang or completely pause when the database functions are being implemented. So we use async.toThread to ensure that the queries don't freeze the entire audio stream. And first we make all the necessary imports. Load our .env file, set up logging, import our Supabase URL and Supabase key. Then we initialize our Supabase client with our key and URL. And this function here is going to be used to normalize the phone number. So it'll strip all the weird characters and spaces and make it look normal. And now we're getting to the part where we will be fetching and writing the data from and to the database. Starting with the first function, get patient. This is the one which will fetch a caller from the database when a caller is calling to recognize that it's a returning caller, or to understand whether it's a returning caller or not. The agent will call this function. The next function is upsert patient. So this is updating a caller's profile after they've booked an appointment. So sometimes a caller would not have booked an appointment before hanging up. So to know whether a caller has actually booked an appointment, in case they ask any questions about it, this function will update their profile on the database when they've booked an appointment. And this next function, increment call count, is to keep track of the number of times a patient has called back. And finally, the most important function, log appointment. This is where an appointment is added to the database. So now that we're done with memory.py, which actually implements everything that needs to be implemented in the database, we are going to create booking.py. So these are the functions that are going to be taking the actions. So this will call the functions from memory.py to take the actions that are required, like booking an appointment or finding an available slot, for example. So to start with, we make all the necessary imports, we set up logging, and I've declared valid doctors here. So if you're using this for any other business, let's say for a hair salon, you can declare the valid hairdressers. These next two functions, format ISO time and spoken from ISO, these will translate the messy timestamps that are used in the database to what is natural in spoken English. So we will say Friday, 12th May, 12:30 p.m., but it will be stored as numbers in the database, and we don't want that to be read out by the agent. And this next function, find available slot, this will scan the database to see the next open slot for a particular doctor. So when a caller says, okay, can you check if this slot is available, this is the function that will be called. And the next one, reserve slot, this is the most important part of this. This is used to make an actual appointment. And here we use atomic log, which is the most important function here. So by requiring .eq status and available, we make sure that the database doesn't double book. So if two callers try to book the same slot at once, only the first caller's booking will succeed and the other one will fail. And finally, we have check slot coverage. This is going to be called in the pre-warm function. It's going to be called on startup to check if there are enough available slots for the next few days. So this will warn us if there are not enough available slots, we'll have to add more slots in the database. Now, the agent does not know how to run the scripts by itself. No LLM knows how to run Python scripts by itself. So there needs to be something that tells the agent that this is what you have to do when to take this particular action. And for this, we create appointment.py. This file will use LiveKit's function tool decorator to tell the agent exactly what to do. So this is almost like a hierarchical structure. So we have memory.py, which is making the database instructions. And now we have appointment.py, which will contain all the instructions for the LLM. So the LLM will call the functions in appointment.py, which will in turn call the functions in booking.py, which will then call the functions in memory.py. It's like a flow. So in appointment.py, which is again supposed to be in the tools folder, we make all the necessary imports. So if you notice here, we are importing booking.py and functions from booking.py and memory.py from the tools folder. And the first function, which is check availability. So this is what the agent will call when it wants to check if there is a slot available. So when a caller asks, okay, is this particular slot with this doctor available? The LLM will first call this, which will then in turn, if you see here, it calls find available slot from booking.py, which calls the function from memory.py to check if there is a slot available. And the next function is book appointment. This is what will actually book a slot and book a proper appointment. This calls reserve slot from from booking.py. And finally, we have a function to get the list of available doctors. So if a caller asks, okay, who are your available doctors? This is the function that the LLM will call. This doesn't have any references to booking.py or memory.py because I have only declared 2 available doctors. So I've just declared them directly here, but you can choose to add it to your database if there are more doctors or again, with the example of the hair salon, more hairdressers. So in build system prompt, now this is where we add the memory. So to recognize a returning caller and to greet them by name, this is where we add it. So first we check if the patient is recognized in the database. If the patient is not recognized in the database, we just return the system prompt as it is. But if they are, we're going to get the last appointment from the database. We're going to get the last time of the appointment and the last doctor that they booked, which is going to be taken as their preferred doctor. And then we're adding another memory block to the system prompt. So this is the caller memory. We're telling it that you already know this caller. You have to greet them by name. Don't ask for their name or any details again. And then we'll give it their last appointment details and be like, okay, this is what you have to use if they want to rebook an appointment or they want to ask any questions about their appointment. And finally, we return the system prompt with the memory block if it is a returning caller. So finally, to bring all of these changes together, we have to make a few changes to our main file, agent.py. This is the central engine of our entire agent. So first of all, we have to add a few imports. We have to call the functions from memory, from booking, from appointment. And then we add a new function at the top called SIP caller phone. So this is to extract the caller's phone number from Twilio's SIP stream. This is to be added to the database so that when the number calls back again, the agent knows that this is a returning caller. And so opening line. So this is where we make the change. So when the agent answers the call, if it is a returning caller, it has to greet them by name. So the opening line cannot be the generic line anymore. So if the patient has been recognized, then we return their name and we tell the agent, okay, say hello. Suppose my name is Arya and I'm calling for the second time. It will say, hi, hello Arya, welcome back to the clinic. And then we return the opening line. And now we need to add our tools. So when we were declaring clinic agent, I told you that we will be adding all our agents tools to this section. So now after instructions, after the instructions, we'll be adding the tools, book appointment, check availability, and get doctor list to the clinic agent to tell the agent that these are the tools you have available for when you need to make an appointment or check the availability or get the list of doctors. The final change to be made to our agent.py is we have to replace the entire entry point function. So this function is available in the blog linked in the description. It is also available on the repo, but since the repo is a final version with all the changes made, it could be a little confusing. I would suggest you refer to the blog in the description. So this function now, it intercepts the SIP connection, gets the phone number, compares the phone number against one in the database to see if it is a returning caller. If it is a returning caller, it generates the personalized opening line for them, plays that opening line instead of the generic opening line. And then the prompt is updated so that the agent knows what their last appointment was and who is the caller who's returning and all of the details that we added in system prompt. And all of this happens before the connection is established so that the agent knows all of this information before it starts talking. So the agent can now book appointments and it can recognize and greet returning callers. But if a caller asks for any static information about the clinic, let's say about parking or about timings, the agent could very confidently hallucinate the wrong answer or say something random. So to prevent this, we are going to be using retrieval augmented generation. Now, using a cloud-based vector database for our RAG would mean adding network round trip time, and in a live, in a conversational voice agent, that would sound like dead air while it fetches the information from a cloud-based database. So instead, we are going to be building a local RAG pipeline. So the agent will chunk, embed, and search through a markdown file that's on your machine using LanceDB, and it will answer the questions instantly and accurately. So starting with the knowledge base, in your project root, create a folder named knowledge, and inside the folder, create clinicfaq.md. So I'm creating this for a clinic, but you can keep the same structure and replace it with the information for any other business that you're creating your receptionist for. So you have to structure the file using the h2 headings, so the double hash headings. So our Python script will use these headings to break the document into chunks. So it will be broken at these headings. So keep this heading format and you can add any information that you want to into this. So I'm going to be talking about what the clinic is, the clinic hours, consultation fees, location, payments, and all of this, and finally all the contact details and everything that a person could ask, that I think a person could ask. So coming to your RAG engine, in your tools folder, create FAQ.py. So we'll be using sentence transformers to turn our text into vectors, and we'll be using LanceDB to store and search the vectors without leaving your machine. So it's going to be a completely local RAG pipeline. Starting with index building and setup. So this happens when the server boots up. So your markdown file is broken down into chunks and stored in the database as soon as the server boots up, so that no time is wasted later on a query to do all of this. So we start up by importing all the necessary modules, and then we declare all our necessary details. So we're telling it that the table is clinic FAQ and where to find clinic FAQ. So our embedding model that we're using here is all mini LM L6v2. And the next one is chunk markdown. So we split the document at all the H2 headings, and each section becomes a chunk. And then we build a LanceDB vector index from clinicfaq.md. So all of these chunks are embedded into vector index, LanceDB vector index. And coming to the next part, which is searching. So this, all of this that we discussed till now happens on startup. So building the database, all of that happens on startup. Now this is when somebody asks for a query. So this is the searching that will happen when somebody asks for a query. So this is a tool that the LLM will call. And first off, sometimes when a vector database is searched, the intent matching could go a little wrong. For example, fees and price, even though they mean the same thing, maybe the matches won't be as accurate for price as it would be for fees, because I've written consultation fees in my headings. So we add a heading boost to boost the relevance based on keywords. So for example, now timing, hour, open, closed, Sunday, holiday, all of these come under clinic hours. And fee, cost, price, all of these come under consultation fees. So I'm giving it a little boost so that the matches happen more, even if the keywords are not matching the heading entirely. So this basically adds a mathematical boost to the search score. So if a keyword matches a section in the heading, it adds a mathematical boost to your search score so that the correct answer is more accurate. And then we make sure that very long blocks of text are not returned, which would be too long to be spoken at once. So we trim them at sentences. We don't want entire paragraphs to be returned at once. And finally, this is the function the LLM actually calls to perform the search. So this is called search FAQ. This tells the agent exactly what to do and how to do the search. First of all, to our system prompt, we need to tell the system prompt exactly how to go about handling and answering the questions that are asked. So we add a section called answering clinic questions in the system prompt. And we tell it that, it needs to call a tool, search the vector database to find the correct answer and not just make up an answer. And next in agent.py, we import FAQs, the functions from FAQ, build index and search FAQ. We add build index to the pre-warm function so that the database is built on startup itself and no time is wasted during a query. And in Clinic Agent, we add Search FAQ as a tool. And finally, in the final function, which will start up your agent, we will check if agent.py is being called with download files. If it is being called with download files, then we run build index and not start up the agent. If it is not called with download files, if it's just called with start or dev, then we start the agent with the correct entry point, pre-warm, and agent functions, just like we were doing before. So if you run Python agent.py download files, it will download your embedding model so that no time is wasted when you're starting the agent. So the downloading of the embedding model could take some time. So we do that before we start the agent so that it saves us time while starting the agent. And now when you start the agent and you make a call and you ask it any questions on the clinic, it will answer based on the contents of the the clinic markdown file that I have added. And if it doesn't know anything, it will say that, it's going to give you a call back and not hallucinate any answers. We have now gone through all three layers. We've wired up the voice loop, we've given our agent memory, we've given it the capability to book appointments, and we've given it a knowledge base to answer questions accurately from. I think it's looking pretty good so far. As I mentioned at the beginning, now we'll be diving into some additional options to make our agent even better. These are not necessary, they're completely optional, but they would make your agent genuinely much more useful. Starting with the calendar mirroring. So after completing a booking, we block off a slot on Google Calendar. So in the clinic's case, it would be on a doctor's calendar, but let's say for the hair salon, it would be on a hairdresser's calendar. So this is just for visibility. So to give human staff visibility into what exactly the agent is doing. I'm not going to be diving into the exact code for the tool. The code is available in a file called calendarmirror.py in the tools folder on the GitHub repo linked in the description. Copy that, drop it into your tools folder. And now coming to the changes that you need to make to your existing files to implement this. In appointment.py, import the new function. So there's a create calendar event function in calendarmirror.py. Import this function from the calendar mirror file from tools. Now we scroll to the book appointment function. So in the book appointment function, there is a line where we call reserve slot. So the reserve slot function is called with await. Just below this, we add async create task, create calendar event. So we're creating an async background task. So this runs in the background without interfering with the functioning of our agent and creates a calendar event on Google Calendar. The next one is WhatsApp confirmation. So after a booking is confirmed, it would be amazing if our agent can send a confirmation on WhatsApp to the caller. So we've covered the setup for this in the Twilio section. If you have any doubts, you can refer to the blog linked in the description. It has the setup steps. The code for this can be found in notification.py in the tools folder on the repo. Coming to the changes, again in appointment.py, there's a send WhatsApp confirmation function in this file. We import that function from the notification file from tools. And just below the task that we just created in book appointment, we create another async task called send WhatsApp and we call the send WhatsApp confirmation function. So this sends the WhatsApp confirmation in the background, again without interfering with the functioning of the agent. So the third one is cancelling and rescheduling, and I think this is a genuinely useful addition to our agent. Because for an AI receptionist to be completely autonomous, it shouldn't just book appointments, it should also manage the appointments. The one risk that comes with implementing cancellation is we don't want our agent to accidentally cancel an appointment. For example, if a caller asks, okay, what is your cancellation policy? We don't want the agent to go ahead and cancel their appointment. So to prevent this, we give our agent instructions to call the function with confirmed equals false first. So confirmed equals false will ensure that our agent doesn't have the capability to cancel the appointment, only to retrieve the information about the appointment and tell it to the caller. And once the caller has confirmed or explicitly mentioned, yes, I want to cancel my appointment, only then does it call the function again with confirmed equals true, this time actually canceling the appointment. So the code for this can be found in the repo in a file called cancellation.py in the tools folder. So drop this file into your tools folder. And coming to the changes, in agent.py, we import the new functions. So this cancellation.py file has two functions, cancel appointment and reschedule appointment. So these two need to be imported at the top of agent.py. And then we add two new tools to the Clinic agent. So in Clinic agent, in the section where we call the tools, we add these two new tools, cancel appointment and reschedule appointment. Coming to the last addition, automatic slot seeding. So when we create our database, it is initially seeded with 14 slots. But these slots are not enough to keep our agent running indefinitely. To make our agent run indefinitely without having to manually add slots every time, we use Supabase edge functions on a cron schedule. So edge functions on Supabase, they run on Dino. So the code is in TypeScript, unlike the rest of our project, which is in Python. You can find this code there's a Supabase folder on the repo, within which there's a functions folder, within which there is a seed slots folder, and inside this there's index.ts. So create these same folders in your repo root and add this index.ts file to the seed slots folder. And then we have to run these commands to deploy it. So first of all, we install the Supabase CLI. Then we link our project, deploy the function, and then schedule it to run every day at midnight. The Clinic persona that I have given my agent is just a thin layer on top of the actual call agent. So this call agent can be adjusted and changed to become a reception agent for any business that you want to make it for. So here are the changes that you need to make to adjust this for whichever business that you're building your receptionist for. Starting with the agent name and persona. So in the system prompt, we need to change our agent's entire persona. It can't talk like a clinic receptionist if it's a receptionist for a hair salon. And we need to change the staff, provider, and table names in the database. So I've given the names according to a clinic. You'll have to change it for whichever business you need it for. The booking flow. So in my booking flow, I've asked my agent to ask for the patient details. I've asked them to ask what they're visiting a doctor for, which doctor they would like to visit. So all of these things need to be adjusted depending on whichever business you're building this for. The business hours and the slots. So the timings need to be adjusted based on your business. The FAQ content. So the content for the knowledge base for the RAG. I have written it based on the clinic. So you'll have to add in your details for whichever business you're building this for, following the format of the headings, the H2 headings, which is what will be used for chunking. The calendar names, my calendars have been built for the two doctors for this clinic. You'll have to change it for whichever business you're building it for. So for example, if it's for a hair salon, you'll have to give the hairdressers names for the calendars. And finally, for the voice, I have used Matthew here, but you can head over to the voice library, explore the voices, and figure out which one works best for your use case. There are also some example prompts and changes given in the GitHub README as well as the blog linked in the description. So I have given you examples of a hair salon, legal intake, and restaurant reservation. So you can use these as a guide to help you adjust this for whichever business that you are going to build your receptionist for. So coming to errors, these are a few errors that I encountered while building this, and I have documented, and I'm telling you exactly how to fix them so that you don't have to waste time looking for the fixes. Starting with the required environment variable. So this usually happens when a required environment variable is not set. So you have to look into the .env.example file on the repo and see if all your environment variables match. The second one, the agent answers but stays silent. So this we discussed this when we were discussing the dispatch rule. If your agent name does not match, the agent name in your code does not match the one in your dispatch rule, or if an agent has not been created at all in your dispatch rule, then this will happen. Your call will still connect, but all you'll hear is silence. So you'll have to make sure that an agent has been created and make sure that the name matches the one in your code. Duplex closed in logs and call drops mid greeting. So usually this happens when you start your agent in dev. So if you do Python agent.py dev instead of Python agent.py start, when you make a change to a file and the file is resaved, then your agent restarts, which makes the call drop mid greeting. So call drops immediately. This usually means that your TWIML bin is not reachable or your SIP URI is missing the transport TCP. So the TWIML bin, we had written we've written in the SIP tag, we've written your SIP URI with your phone number, and we've written a transport equals TCP at the end. If this is missing, then your call will drop immediately. So you'll have to check on these and fix them if this happens. So if you get a slots does not exist or slots is missing at seat time error, it usually means that your table has either run out of slots or you've only run a part of the table creation code. So go to SQL, create tables.sql, copy the entire thing, drop it into your SQL editor and run it to make sure that all the tables have been created properly. If you get a 401 or a 403 from Murf or DeepGram, it usually means that there's an issue with your API key. Either your API key is wrong or it has expired and you'll have to go get a new one from the console. WhatsApp message not delivered. So if you've set up WhatsApp confirmation and your WhatsApp message is not getting delivered, it usually means that your recipient has not joined the sandbox. So if you're using the sandbox and then this sandbox connection will expire every 5 days. So the recipient will have to join the sandbox again every 5 days. So if the calendar events are not appearing, it usually means that your service account has not been shared with the calendar. Make sure that this has been done. Slot coverage warning on startup. So since we've added the check slot coverage function to the pre-warm, on startup, if there's a slot coverage warning, it usually means that there are fewer than 14 slots available. So this could, if you've enabled automatic slot seeding, this could mean there's an issue with your Supabase Edge function. You'll have to check on that. Or you have to manually add more slots to your database. So in this tutorial, we have built a fully autonomous AI voice receptionist that can answer your calls, book appointments for you, has memory, and can answer all your questions instantly and accurately. The complete ready-to-run source code is available in the repo linked in the description. You can clone the repo, you can swap out the system prompt, make your changes as mentioned in the adjusting the use case section, and build your own receptionist. If you've built something interesting using the stack, we'd love to hear about it. Head over to the comments and let me know what you've built and what your agent is booking. I'll see you in the next one.